Hello and welcome to the application section of the National 5 video tutorials. Today we're going to look at magnitudes of vectors. So to find the magnitude of a vector, what you need to do is you need to take each separate component of the vector, so in this case -2, 5 and 4, you need to square each of them and then you need to take the square root of the resultant number. This question is a non-calculator question. It asks you to give your answer as asserted in its simplest form, so we're going to try that now. First of all, we need to square each of the numbers, so we're going to do -2 squared plus 5 squared plus 4 squared, and we're going to square root the result. Okay, so -2 squared is 4, 5 squared is 25, and 4 squared is 16. If we add all those together, 4 add 25 is 29, add on 16, that's 45. It asks you to leave your answer as asserted in its simplest form, so we need to find a square number that goes into 45. The square number that goes into 45 is 9, and you have to multiply that by 5 in order to make 45. So our final answer here, the square root of 9 is 3, that's our normal number outside our third bracket, and square root of 5 stays inside the third bracket. Okay, our answer is 3 root 5 for that one. Okay, so a lot of times you're asked for the magnitude of a combination of vectors. So in this case we're asked for 2w's plus on v. We need to figure out what that is first, so we need to find what two lots of vector w, that's -1, 8, -3, add on a vector v -2, -11, 8 is. Okay, so 2 times vector w, 2 -1s are -2, 2 8s are 16, 2 -3s are -6, add on -2, -11, and 8. Okay, so -2 add on -2 gives you a -4. 16 add on -11 gives you +5, and -6 add on 8, that gives you +2. So this is the vector that we're finding the magnitude of. So what we need to do is we need to do our square root again. Square root of -4 squared plus on 5 squared plus on 2 squared. That's going to give us the square root of 16, add 25, add 4. Those are the three numbers we had in the last example, so that's square root of 45. Alright, but this time we've got a calculator, okay? So we can figure out an exact value for this square root. I'm going to revise my answer and give it to 2 decimal places. So square root of 45 is actually equal to 6.71 if you put that into a calculator. And that's our final answer there, 6.71. Okay, so now that you've seen how it's done, here are 3 non-calculator examples and 3 calculator examples for you. The ones on the left hand side are non-calculator, the ones on the right hand side are calculator, as indicated by the pictures. Give your answers on the left hand side in asserted in its simplest form. On the right hand side, give it as a decimal. Pause the video now and I'll give you the answers in just a moment. Okay, so for example A, you should have got the answer 7, or square root 49, which is equal to 7. For question B, you should have got 2 root 6, and for question C, you should have got 5 root 5 as your fully simplified answers. For question D, 19.52, for question E, 10.68, and for question F, 24.43. Those are your answers. If you'd like to try some exam-style examples on magnitudes of vectors, then here are your SQA links. Remember, you can download these papers from the SQA website for free. Keep revising hard, and thank you for watching as always.